I'm going to try to clarify a few things for you using example 16 on page 741. You did vector addition before, and when you did vector addition, in other words, adding two vectors together to find what's called the resultant vector, you added the x's and you added the y's, which that's no problem at all. So the resultant vector here would be 2, 16. And when you added these before, when they showed it to you pictorially, they talked about adding them together by putting the initial pieces together, or adding them together using the parallelogram method. Now, the parallelogram method will keep you from messing up when it comes to finding angles between the vectors, because at least then that way you can actually see which angle they're talking about. So when I add two vectors, I prefer to actually take the position vector and draw it out. So what I'll do is I'll find the magnitude of each vector. And a lot of times in books, the magnitude is depicted as a bold letter from the original vector. So you would see that U vector being very bold and the V being very bold, and that would tell you that it is done with the magnitude. So the magnitude is found by squaring each piece of it and then adding them together and taking the square root, which is how you use the Pythagorean theorem. So for the magnitude of U, we would get -3 squared is 9, plus 4 squared is 16. So 9 plus 16 is 25, and the square root of 25 is 5. So we would bold this U and say 5. And we would bold the V, and we would say that's 25 plus 144, which is 169, so that's 13 when you take the square root of it. Now, the easiest way to add these together is to do the parallelogram method and just take one of the vectors and draw it out and say, okay, that's 5, because that's its magnitude. The other vector is 13, and we're not drawing it to scale. We're not drawing the angle to scale. But the easy way to add these two together and get a resultant for the magnitude of the third vector, the U plus V, is to draw a line between them and connect it like a parallelogram. Because when you do that in a parallelogram, the sides that are opposite are the same, and it makes it easier then to find the missing pieces. So what I did is I took the vector that we added together and I found the resultant of it, the magnitude of it, which would be 2 squared is 4, plus 16 squared is 256. So the square root of 260 would be roughly 16.1, and that gives you the length of that piece, that vector that is U plus V. That's the magnitude of that vector. So when it says in that problem that it wants you to find the angle between them, it is actually talking about this angle right here, which is between the two vectors that you drew. And you can easily use these principles of the parallelogram, because this angle and this angle added together is 180 degrees. So if you could use your law of cosines to find this angle, you could subtract it from 180 and you would have the angle that you're looking for. And we do this a lot when we're talking about pulleys, like if we had two forces that were acting on an object and it was holding the object in place with a pulley system, you would need to know how big these two forces needed to be to come together to hold whatever object that we had in place. So that's the use of this. So when I take this and I use the law of cosines and I say, okay, I'm going to try to find this angle, I use my law of cosines and I say 16.1 squared equals 5 squared, which is 25, plus 13 squared, minus 2 times 5 times 13 times cosine of x. And when I do my math, and I do 161 squared minus 25 minus 169 and divide it by this number and then take the inverse cosine, I get roughly 120.1, and that's a little off from what they got in the book because of the way that I rounded. And so that means that this x value is 120.1, and if I subtract that from 180, I get that the angle between them is 59.9 degrees. And so that's what we're looking for without having to find unit vectors and different component vectors and learning new definitions. We can use our law of cosines to figure this out and be able to do this.